Hey there, Mr. Weaver here, and this is Module 6, Lesson 1, Solving One-Step Inequalities. After this lesson, you need to be able to graph the solutions of an inequality, solve linear equalities by using addition or subtraction, and solve linear inequalities by multiplying or dividing. Let's learn graphing inequalities. An inequality is a mathematical sentence containing one of the following symbols. You should have seen these four in previous grades. However, we also have this last one that represents not equal. An inequality means something is not equal. So we also have that symbol. An inequality compares the value of two numbers or expressions using those symbols. Example 1. Graph inequalities. Graph the solution set of y is less than or equal to 4. Here they have the graph already given to us. We can see there's a circle here on the number line at 4, and there is an arrow going in a specific direction. So the dot at 4 shows us that 4 is a solution. And I can tell that it is a solution because that dot is closed or colored in. The arrow is pointing to the left, showing that the solution includes all of the numbers that are less than 4. So I can see that in this symbol, my solutions for y can be equal to 4 or less. So anything that fits in the arrow is going to be a possible solution. Unlike an equation, inequalities have many solutions. So for example, if I had to list out solutions, I could say that 1 is a solution because it is less than or equal to 4. I could say -4 is a solution. It's less than 4. Anything in that arrow would work as a solution. And because that dot is colored in, 4 would also be a solution. So as we go through this, you need to be thinking about all of the possible things that could happen when we're solving the inequalities. And the circle is just going to go at either the lowest possible point or the highest possible point. And that's called the boundary. Check your understanding. Graph the solution set for y is greater than 1/2. Pause the video now and complete the check. Check your answer. First, we need to have an open circle this time. Now, in the previous, we saw a closed circle because it was colored in. This one does not have the line under it. So we have to have an open circle showing that 1/2 cannot be an answer. But then we want everything greater than 1/2. So our arrow is going to point to numbers that are greater than 1/2, such as 2. That's greater than 1/2, or 3. That's greater than 1/2. The key here, though, if you see this symbol or this symbol, you're going to draw an open circle. If you see with a line under it, the greater than or equal to, that's where you would have it colored in. Example 2, write inequalities from a graph. Write an inequality that represents the graph. So here we can see we have an open circle at 1.4 and the arrow pointing to the left. So the endpoint is shown with a circle at 1.4, but because it is open, it is not included in the solution, which means it must be one of those two symbols right there, either just greater than or just less than. We also see the arrow points to the left. So those are the values that are less than 1.4. So this graph would be a solution for the equation of a is less than 1.4. We could have picked any variable we wanted, but here we chose a. Check your understanding. Write an inequality that represents the graph shown. Pause the video now and complete the check. Check your answer. You should have said x is greater than or equal to -10, or whatever variable you chose. We can see our circle at -10, so that's our boundary number. It is colored in, so it's a closed circle, meaning it has to be one of the greater than or equal to signs, or less than or equal to. And then the arrow going to the right, showing our greater numbers. All the numbers here are larger than -10. So our solution is x is greater than or equal to negative 10. Let's learn solving inequalities by using addition and subtraction. Just like equations, addition and subtraction can be used to solve inequalities. Back in Module 2, we learned about some key concept called the addition and subtraction properties of equations. And that said where we can add or subtract the same thing to both sides and make the equation still true. Well, these properties of inequalities are pretty much the same thing. For the addition property, if we add the same thing to both sides, our inequality is still true. And if we subtract the same thing from both sides, our inequality is still true. So we can use those same types of properties to help us solve for our inequalities. When we're solving inequalities, we can also write our solution set in a specific way called set builder notation. So in our last example, when we were writing, we had x was greater than or equal to negative 10. When we're solving it, we can write it so it looks like this. It shows us that we're solving for x and we're representing all the numbers where x is whatever we got for our answer. So here they're saying that x is greater than or equal to negative 4, and all the numbers that fit that for x would be included. Example 3. Solve inequalities by adding. Solve x minus 10 is less than 15. We're going to solve these the same way we did as if this was an equal sign. If it helps to draw the line, like we may have done before, go for it. So we're going to start by trying to isolate our variable by doing the opposite of what we see to both sides. So here I see minus 10, so I need to add 10 to both sides. That way, on the side of the variable, it cancels out. By adding 10 to both sides, I'm left with x on the left, and then 15 plus 10 is 25. So our solution set is all of our values of x when x is less than 25. Check your understanding. Solve negative 9 plus b is less than or equal to 16. Pause the video now and complete the check. Check your answer. Your solution set should be all the values of b when b is less than or equal to 25. To solve this, we would just add 9 to both sides. If you subtracted, remember, the symbol that you need to do the opposite of is in front of the number you're trying to do it to. So here I see minus 9, adding 9 to both sides. I would end up with b less than or equal to, and then 16 plus 9 is 25. Example 4. Solve inequalities by subtracting. Solve x plus 24 is greater than or equal to 61. This time I see plus 24, so doing the opposite of that, I would need to subtract 24 from both sides. That's my one step I need to do to get x by itself. So x must be greater than or equal to 37. Notice here, as I'm going through these, whatever symbol I start with is whatever symbol I end with. And for now, they are facing the same direction. Sometimes they'll switch, and we'll look at that in a later example. But make sure you are keeping the same sign throughout. It cannot switch from greater than or equal to just greater than halfway through the problem. So here our final solution set would be all the values of x when x is greater than or equal to 37. Check your understanding. Write the solution set for 88 is less than x plus 13. Pause the video now and complete the check. Check your answer. You should have said all the values of x when x is greater than 75. To get that, I would do the opposite of 13, because here's my x, so to both sides. There's where I get my 75, and keep the same symbol, x. In the solution set, they just switched it around, putting x on the left, 75 on the right. Notice x was greater, right? If you remember, way back in like 3rd grade, the alligator eats the grater. If you switch it, you need to make sure that the inequality symbol is going the same direction. So x was greater than 75. Example 5. Add or subtract to solve inequalities with variables on each side. In Module 2, we also looked at what to do to solve equations with a variable on each side. And we solve it the same way as if there's a number on each side. We just add or subtract what we need to get rid of it off of one side, and then do the same thing to the other. So if I want to solve 9y plus 3 is greater than or equal to 10y, I see I have a variable on both sides. This left side has my number, my constant, so I want to move things away from that. That way I end up with a variable on one side and a constant on the other. So to get rid of that 9y, I would have to subtract it. It would be gone off the left. Then I need to do the same thing to the right. 10y minus 9y is 1y. And then on the left side, we're just left with 3. So here, our inequality is 3 is greater than or equal to y. And just like I showed in the last check, 3 is greater than or equal to y is the same as y is less than or equal to 3. So we can switch it around and say all values of y when y is less than or equal to 3. Check your understanding. Write the solution set for 7x plus 6 is less than 8x. Pause the video now and complete the check. Check your answer. You should have said all values of x when x is greater than 6. To get that, we would just subtract 7x from both sides. This side leaves us with 1x. Let's keep our symbol. 6 is less than x. Again, flip it completely and we'd end up with x is greater than 6. We haven't done it yet in any of the problems, but if we want to check our answer, we would do just like we did with an equation, take what we got, and if we were to plug it back in for x, instead of it being our symbol here, we're just going to say it's equal. We know that that's the boundary. So if we were to plug it back in, 7 times 6 is 42, plus 6 more is 48. If you come out with it being equal, then you are good. You would just keep the symbol as what it is originally, as we did, but when you're checking your answer, you can always just pretend that it's equal because the boundary is when it would be equal. And that is what you are finding is the boundary value. Example 6. Use an inequality to solve a problem. Our real context here is data usage. Hassan's wireless contract allows him to use at most 5 gigabytes, or GB, of data each month. At this point, Hassan has used 3.7 gigabytes of data. How many gigabytes of data can Hassan use during the rest of the month without exceeding the maximum allowance? Complete the table to write an inequality to represent how many gigabytes of data Hassan can use. Then, solve the inequality. So we're going to use this table to put our words into an inequality. So first, Hassan can use at most 5 gigabytes each month. That's what it tells us in the first sentence. If we let G equal the number of gigabytes, logically that letter makes sense, then that can be how much he has left to use. So if we're writing an inequality, his total usage right now is 3.7, which is what he's used, plus G, what he can still use, and that can be at most 5. For inequalities, the words at most and at least are almost backwards in your thinking about which symbol to use. At most means you can only use less than that number, whereas at least means you have to use more than that number. So Hassan needs his usage to be less than 5, but it could also be exactly equal to 5 and he'd still be okay. So at most actually means he has to use less. So when you're doing problems in context, be careful for those words. Now that we have our inequality, we're going to solve it by subtracting 3.7 from both sides. Careful, this is really positive 3.7. Remember, we use the sign that's in front of the number. So we would subtract 3.7 from both sides. We can find that Hassan has 1.3 gigabytes left. So his solution, all of the gigabytes as long as the gigabytes is less than 1.3 or equal to 1.3. So he can use up to 1.3 gigabytes without exceeding his maximum allowance. When we're solving this, also notice we technically could have a negative number part of the solution, right? -5 is less than or equal to 1.3, but that doesn't make sense in this context, so it is not part of a viable solution set because he can't use a negative amount of data. So maybe another way we could say is he could use more than or equal to 0 or less than or equal to 1.3. That way, we're not including our negative numbers. Let's learn solving inequalities using multiplication and division. If you multiply each side of an inequality by a positive number, then the inequality remains true, just like adding or subtracting. However, if you multiply an inequality by a negative number, then you must change the direction of the inequality symbol in order for you to keep it true. This is because when you multiply by a negative number on a number line, when you multiply, it switches sides of the number line. So you have to switch the direction of the inequality. If it was negative and you multiply it by negative, it goes to positive now. If it was positive and you multiply by negative, it goes over to the negative side. So you have to remember to flip the inequality symbol if you multiply or divide by a negative. So let's look at our key concept, the multiplication property of inequalities. This here is stating pretty much what I just explained. If you multiply by a positive number, so multiplying both sides by c, notice the direction stays the same because c was positive. If you multiply by a negative number, so if this was -2, then the inequality needs to flip. So let's say that this is originally 2 and this is originally 1. If we multiply by -2, now we got -4 and -2. Which one's actually greater now? It's flipped to the other direction. So here our division property of inequalities, same thing as we saw with equations. If you divide both sides by a number, you will still have a true inequality. Just be careful of the negatives. Example 8. Solve an inequality by multiplying. Solve -2/5 x is less than or equal to 11, then graph the solution on the number line. In previous lesson, we learned that to undo a fraction, we just multiply both sides by the reciprocal. So if we multiply both sides by -2/5, so the reciprocal is just flipped, and then it was negative, so multiply by negative, then we'll get rid of the fraction. So this will cancel out. 11 times -5/2 ends up being -27.5. Or we could have said -55/2. We can leave it, it doesn't reduce. Might as well leave that improper fraction. The key here though, we multiplied by a negative value, meaning we have to flip the inequality sign. So it started where it was kind of opening to the right, now it's facing the other direction. So originally x was less than, now x is greater than. So our solution set, all values of x when x is greater than or equal to -27.5. Graphing that, I'm going to put my closed circle at -27.5. Remember, it's colored in because it has the line under it. It's or equal to. Then, all the values that are greater, so to the right. If I forget to flip my inequality sign, what ends up happening is my circle might be in the right place, but the arrow is now pointing the wrong direction. Example 9. Solve an inequality by dividing. Solve 20x is less than 4. Graph the solution set on a number line. So 20x is less than 4. We just need to divide both sides by 20 to get x by itself. So x would be less than 1/5 or 0.2. So our solution set, all values of x where x is less than 1/5. Graphing that on the number line, 1/5 would be about there. We would have an open, not colored in circle because there's no line under our symbol. And x is less, so the arrow would go to the left. Those are the values of the less numbers. Check your understanding. Solve 7x is greater than negative 161. Pause the video now and complete the check. Check your answer. You should have said all values of x when x is greater than negative 23. To get that, we would just divide both sides by 7. We don't have to flip the inequality sign because we did not divide by a negative number. Even though there's a negative in it, the number we divided by wasn't negative, so keep the symbol the same. Example 10. Solve an inequality with a negative coefficient. Solve negative 13z is greater than or equal to 117. Graph the solution set on a number line. To solve this, I would need to divide both sides by negative 13, and I would end up with negative 9. This time, we divided by a negative value. Just like when we multiplied by the negative value, we have to flip the inequality sign. So it was facing one direction, now it's facing the opposite direction. Our solution set is the values of z when z is less than or equal to negative 9. Graphing that, close circle at negative 9, and since z is less, arrow would go to the left. Check your understanding. Select the solution set for negative 13x is greater than negative 169. Pause the video now and complete the check. Check your answer. You should have picked B. Dividing both sides by negative 13 means that you get x and 13, but because we divided by a negative value, we have to flip the sign, so B.